Hi folks, and welcome to tonight's live stream on the chain rule. And basically what we're going to be looking at is just taking the derivatives of a bunch of functions that involve this chain rule. And what is the chain rule? Well, it's essentially taking derivatives when you have a composition of functions. So what you're looking at is the derivative of f composed with g of x. And what that derivative actually equals, well, it's going to be f prime of g of x, so we leave that inner function unchanged while we take the derivative of that outer function, and then multiply by g prime of x. Okay, so as always, if you have any questions along the way, please post them. I know this might be a little bit challenging material, but this is kind of the backbone of the derivatives, and as long as you know power rule, quotient rule, and product rule, this is the main rule that we kind of combine them all together at once. So without further ado, let's get started. We're going to find the derivative of the following functions. And so for the first one, we have f of x equals this quantity 4x squared minus 7x plus 6 to the fourth power. Now you could expand this, but that's going to be a pain in the butt because you don't just take every power to the fourth. You got to basically distribute to each term multiple times, so to the fourth power, and you're going to have a trinomial there, so that's not an easy task whatsoever. So keeping that in mind, how do we actually approach this with the chain rule? Well, we look at what is our outer function, right? And our outer function is essentially this raising to the fourth power. And so when we raise something to the fourth power, we essentially use the power rule. And so what we'll do is we'll bring that 4 on down, use the power rule just how we normally would. So 4x squared minus 7x plus 6, and then raise to the 4 minus 1 power, which is just the third. Then we have to take the derivative of the inner function. And what we'll do is, rather than write it all on one line, we can write times the derivative of 4x squared minus 7x and then plus 6. So you can see we move kind of faster. If you don't know the power rule, this is going to be a lot more difficult, but recognizing what that outer function is, that becomes quite important here. So moving forward from this part, notice we get 4 times the quantity 4x squared minus 7x plus 6. Now notice we're cubing this, but then we're multiplying by the whole derivative, not just the first term. So what we need to do is put parentheses around what that derivative is going to be. So 4 times x squared, well, that'll be 4 times the derivative of x squared is going to be 2x. So 4 times 2 makes 8, and then we have x. And the antiderivative, sorry, just did a calculus video a little while ago, calc 2. And so minus 7x, the derivative, sorry about that, derivative of negative 7x is just negative 7. And the derivative of plus 6 is just 0, so we can close that thing off. Okay, so we have our derivative. This is our final answer, and that is the chain rule being applied. Now, all of these can look kind of different, and sometimes it's tricky to figure out what the outer function and the inner function is. And so for this case, let's take a look. So you have, in this case, we have secant cubed of 2x. Another way for us to write this to recognize what is that outermost function, we can write this as secant of 2x, the quantity, cubed. And that might look a little bit better for most of you. If not, no big deal. But you can now see for certain the outermost function, we have a power raised here. So what happens is we use the power rule. We get 3 times secant of 2x. And then power rule means this will be the 3 minus 1 power, so that's a square. And then this must be the derivative of the interior function, or so the inner function. What is it? Well, notice inside we have secant of 2x. So the derivative of secant of 2x. And so this is where it can get a bit trickier. Well, what happens? You get 3, and then we can rewrite this. We can bring the square back to where it normally is. 3 secant squared of 2x. So what's the derivative of secant? Notice you have an outer and inner function here. The outer function is the secant. The inner function is the 2x. Well, the derivative of secant is usually secant x and then tangent x. But instead of secant x, you have secant of 2x times tangent of 2x. And then all that will be times the derivative of the inner function, which is 2x. So notice we've used the chain rule multiple times in a problem, and that can happen. We can use the chain rule as many times as necessary. So the derivative of 2x, hopefully that'll be a little bit easier. Notice we have 3, and I'll not simplify just yet. Secant squared 2x, and you don't have to simplify. Sometimes it looks nicer. You saw the previous one, we didn't really simplify too much. So we have secant 2x, tangent of 2x. And what's the derivative of 2x? Well, it's just 2. So this whole thing, notice you have 3 times 2, that makes 6. And then you have a secant squared 2x and a secant 2x, that makes secant cubed of 2x. And then a tangent of 2x. And once again, that's just the chain rule being applied. And so we're good to go there. So we'll try a few more and we'll see some more complicated examples, and some maybe they're easier to you. I wanted to see a wide variety of examples in terms of what's going on here. So in terms of finding the derivative, if you look at this one, what's our outermost function that we're dealing with? Well, it's the 9. Once again, it's power rule. Okay, so hopefully we'll see one later on where we don't have to do the power rule first. But so you get 7x to the 4th minus tan cubed x. And then this is raised to the 9 minus 1 power, which is the 8th power, just by applying the power rule. And then that is times the derivative of 7x to the 4th minus tangent cubed x. And just to make a minor change here, to make our lives just slightly easier, I'm going to rewrite that second one. Rather than write tan cubed x, I'm going to write tangent of x, the quantity cubed. That way that might look a little nicer for most of you. And if you can skip that step, feel free to as well. I'm not saying you have to do that. It's just something that might help people see. So this becomes 9 times the quantity 7x to the 4th minus tan cubed x, all raised to 8th power. Now remember, we're supposed to multiply by the whole derivative, so we need to use parentheses. So what's the derivative of 7x to the 4th? Well, that becomes 7 times, and then the derivative of x to the 4th is 4x cubed. So 7 times 4 makes 28. And then we have an x cubed. Minus, what's the derivative of tangent of x, the quantity cube? Well, notice we need to use a chain rule on this part. So the outer function is once again the 3, so we can go 3 tan x, so the tangent of x, and then we're going to go to the 3 minus 1 power, which is 2. But we need to take the derivative of the inner function on this part. And I want to explain something here. Notice, this derivative is only multiplied by the part where we're using the chain rule, and it's times that 3 tangent x squared, x the quantity squared there. It's not multiplied by the 28x cubed, and this is where people can get tripped up, is where the parentheses go and things like that. So just beware in terms of what's happening here, where we're putting all these things. So this simplifies down to 9 times 7x to the 4th minus tangent cubed x, all raised to the 8th power, and that is multiplied by 28x cubed. And then minus 3, we can move that tan squared to where we need it to be. So 3 tan squared x. And now we can multiply by that derivative that we're looking for. What's the derivative of tangent of x? Well, it's secant squared x. And remember, if you're struggling with these derivatives, my biggest suggestion is have the list of the derivatives, especially the trig functions and things like that, right next to you when you're first learning them. Now, the more you practice them, the easier they get, and you can start to do them in your head a lot quicker. Okay, so hopefully that made sense on the derivative of that function. And I don't see any questions. Once again, if there are any questions along the way, or you need me to slow down, cover something a little bit slower, you don't see a step, please just let me know. That's what I'm here for. I'm just here to help as much as possible. So in our next function, what is actually our outer and inner, right? Well, notice usually what we have is the derivative of e to the x equals e to the x, right? But we don't have that anymore. We have this e to the x cubed plus x sine x. So in this case, what happens is we'll still take the derivative of the e, because that's essentially, we have our base there. We're going to have that behave the same way that we were having other functions behave, but we don't have x up there anymore, and since that's no longer x, we have to take the derivative of that part, and that's the chain rule applied to an exponential function. So we need to multiply by the derivative of x cubed plus x sine of x. And so what does this become? Well, this is, we can write e to the x cubed plus x sine x times, remember once again we need to put parentheses here, and I'll give you all a shot if you want to, give you a minute or so. What rule do we need to use in order to take the derivative of x sine x? Any ideas? So x sine x, we need to use something in order to take that derivative there. What rule do we need to use? So it might be tricky at first, but at the end of the day, notice you have a product of two functions. So what that means is we need to use the product rule. And so we take the derivative with respect to x of x times sine of x plus x times the derivative with respect to x of sine of x. Then we can close that thing off. So this whole thing, what does it equal? Well, we get e to the x cubed plus x sine of x times 3x squared. Notice the derivative of x is 1, so you're left with just sine of x in that first term, plus x times the derivative of sine of x is cosine x, and we can close off our solution for our derivative. Okay, so hopefully that makes sense on that one. And now you can see we can have chain rule and product rule involved at the same time. So obviously the next question that kind of pops up, can we use a quotient rule as well? And the answer is yes. We can start doing quotient rules along with this. So notice in this case you have a quotient right out the gate, and there is no outermost or innermost that we're worried about just yet. So what we'll do is we'll use that quotient rule. We'll take this x cubed minus 7x and square it. Oh, and just in case you don't remember, I'll give you a shorthand here. If we have f over g, the derivative, you basically take g squared, and then it goes f prime g minus f and then g prime. So you square the bottom, and then it goes low d high minus high d low, and the d stands for take the derivative. Low would be the denominator, and high would be the numerator, is what's going on there. So in this case we need the derivative with respect to x of cosine of e to the 3x times the quantity x cubed minus 7x. Oops, I don't need that squared. That's only in the denominator. And then minus, well, we'll just write the numerator first, just to be consistent, times the derivative of the denominator. Okay, so when you take a look at this, notice that first one, you have an outer function and an inner function. The outer function is actually a cosine, so no longer a power rule right out the gate. So what that means is we're going to need to use a chain rule with the derivative of cosine, which is negative sine of e to the 3x, times the derivative of the interior function, which is derivative of e to the 3x, and then that would be times x cubed minus 7x, and then we go minus cosine of e to the 3x power, and the derivative of x cubed is 3x squared, and the derivative of 7x is just 7, and all that is over x cubed minus 7x, the quantity squared. So where do we go from here? Well, the derivative of e to the 3x, we just kind of talked about that. I'm actually going to write that up here just for space's sake. So notice that would be the derivative of e to the 3x. We just write that down, but notice we don't have just x up there, so we need to take that derivative of what's up in the exponent. So take the derivative of 3x. So that derivative of 3x is just 3. So we get negative sine e to the 3x times e to the 3x, and then times 3, and all that's times x cubed minus 7x, minus cosine of e to the 3x times 3x squared minus 7, and all that is over x cubed minus 7x, the quantity squared. And you don't have to worry about simplifying. Just if you were to punch this in to say WebWork or something, just put everything in parentheses and then make sure you put the whole denominator in parentheses. So everything in the numerator in parentheses, and same thing with the denominator, and you're good to go. Okay. And so this last one, what we're going to see, so notice there we use the quotient rule first, then we use the chain rule. In this case, though, we're going to use the chain rule first, and then we're going to use the quotient rule after. So to help us out first, we'll rewrite this. This is cosine of natural log of x over x to the 5th. Don't let your eyes fool you, that's a 5. And then we're taking that whole thing and squaring. So we're back to the power rule first. So this becomes 2 cosine of natural log of x over x to the 5th raised to the first power. So well, I'll put it in there now, but it won't make much of a difference in terms of what happens. And then times the derivative of the interior function, which is cosine of natural log of x over x to the 5th. Okay. And so this whole thing becomes 2 cosine of natural log of x over x to the 5th times, what's the derivative of cosine? Well, it's going to be, notice we have an outer function being cosine, the inner function is that natural log business. So this would be negative sine of, we remember we still write the g of x inside, so whatever's inside we just write it again. But then we have to use a chain rule once again to take the derivative of natural log of x over x to the 5th. But notice that's a quotient rule problem. So we have a quotient, we'll use the quotient rule. So you have 2 cosine of natural log of x over x to the 5th times negative sine natural log of x over x to the 5th. And so this one isn't too bad. Times, so first thing you do, you square the denominator. So we'll try and do this kind of in one step. So if I take x to the 5th and I square that, what does that become? Well, it's not too bad. You can rewrite that as just x to the 5 times 2 power, which is x to the 10th. Now what do? Well, we take x to the 5th, and that'll be up top, but so this will be 1 over x is the derivative of natural log of x, so 1 over x times x to the 5th minus natural log of x times derivative of the denominator now, so that would be 5x to the 4th. And we can close off our parentheses, and notice we finished the problem. So any questions on that quotient rule that we finished with? And please let me know if you have them. That's what I'm here for. So just if you have any questions, let me know. But without seeing any other questions, I guess I'll move on. So keeping the trend going along. And as I said, just put a question in the chat box if you have it. So here's one of the more difficult sort of problems that you'll encounter. Let me kind of erase some of this, and we'll try and make it nicer. So what does this become? Well, this would be, another way to write it is e to the 3x, and this is going to be a whole quantity raised to the 1/2 plus cosine of 2x plus an x cubed minus 9x squared, and that one is raised to the 1/2, but then we'll close off that one with the cosine, that thing's raised to the 1/2, and then we'll close off that thing with the e to the 3x, and that thing's raised to the 1/2. So you see a whole bunch of 1/2 powers in here, and so this is a nested square root, and it can cause all sorts of confusion. But don't let it. All we need to do is just use our good old-fashioned power rule once again, because the 1/2 on the outermost part is what we're looking at. So you have 1/2 times, write down all the junk on the inside. Now you have a couple ways to do it. You can write e to the 3x plus, if you want to use the 1/2 powers and all that junk, that's fine. But for now, making the transition, I'm going to go back to the square roots for just a second, and I'll go back to the 1/2s whenever I need to make a derivative change. So this is, we have this plus the square root of x cubed minus 9x squared, and all of that is raised to the 1/2 minus 1, which is negative 1/2 power. Okay? So times the derivative, now here's the fun part, we got to multiply by the derivative of the interior. So what is that interior? Now is where I'll write it in terms of the extra pieces here. So you have e to the 3x plus cosine of 2x plus x cubed minus 9x squared, and that one's raised to the 1/2, and this one's raised to the 1/2. But notice the e to the 3x is not anymore, so because we already took care of that. So what that does is we have 1/2, and then you can rewrite this actually. That negative 1/2 just becomes 1 over the square root of e to the 3x plus square root of cosine of 2x plus another square root x cubed minus 9x squared. So real quick note, this derivative, so derivative of e to the 3x, remember we're going to need to use a chain rule, so this goes e to the 3x times the derivative of 3x, because 3x is up in the exponent. So that equals e to the 3x times 3, or another way for us to write that is 3e to the 3x. And so that's what you'll see me right here. So remember, all this needs to be in parentheses, so you get a 3e to the 3x for that first part. Now what about the next part? Well, notice all this is an inner function, and the outer is that 1/2 power. So notice when we take the derivative of cosine of 2x plus, and for now I'll just write it as a square root just to keep track, x cubed minus 9x squared. That's the 1/2 power. And then this whole thing is raised to the 1/2. What do? Well, we start with the 1/2 times all that junk. So the cosine of 2x plus the square root of x cubed minus 9x squared. And then it's raised to the 1/2 minus 1, which is negative 1/2 power. Okay, but now what we need to do is we need to take the derivative of the interior. So that's the cosine of 2x, and here's where I'll write it back in terms of the 1/2 power, plus x cubed minus 9x squared. That whole thing raised to the 1/2. Okay, so we'll talk about this along the way. So we have 3e to the 3x, we got that part. So the next part though, remember it's going to be 1/2. We have cosine of 2x plus the square root, let me put that in parentheses, plus the square root of x cubed minus 9x squared, and all that's raised to the negative 1/2. Okay? But then we need to multiply not the first piece, just this last piece, times the derivative of cosine of 2x plus x cubed minus 9x squared raised to the 1/2 power. And then, so we can close off our parentheses because all that's multiplied by that first business. So what happens here? Well, let's talk about that. So we're focused now on this derivative. Okay, so I'll erase that bottom piece. So you see a plus, so we're going to have to take two separate derivatives. So derivative of cosine of 2x. Let's talk about that. Okay. So derivative of cosine of 2x, notice we're going to need to use the chain rule. The outermost function is the cosine. And so the derivative of that is negative sine. And so we put the original function on the inside, and then times the derivative of the interior. Now what's the derivative there? Well, you get negative sine of 2x. Derivative of 2x is just 2. So multiply by 2. Okay, so we're done with this first portion. Okay, so now we need to take the derivative of the second term. So you have x cubed minus 9x squared raised to the 1/2 power. Notice the outermost part is that 1/2 power, so you're left with 1/2 using the power rule, x cubed minus 9x squared raised to the 1/2 minus 1, which is negative 1/2 power. And then all that needs to be multiplied by the derivative of the inside. Okay, so let's see. I'm going to erase this portion then in here, just for the sake of having room. Because we need the derivative of this last piece, what we're looking at. And remember, it's all multiplied. So with the plus symbol in between the two pieces. So the first part, notice we have negative sine of 2x times 2. I'll just write that as negative 2 sine of 2x. And then for the second part, we have plus 1/2 x cubed minus 9x squared raised to the negative 1/2 power. And then times the derivative of x cubed minus 9x squared. Can we fit it in there? Oh yes. Okay, good. Phew. So really this whole problem just boils down now to this derivative right here. And we'll do that in purple. Well, that derivative is just 3x squared minus 18x, just by using the power rule. So what we can do, as long as we make sure to put that piece in parentheses, we'll take this apart. Times 3x squared minus 18x. Now this problem is pretty difficult, right? It might take you a few times to go through and actually figure it out, what's going on, but I guarantee if you can do this, you can do any chain rule problem. That's the whole trick to it. As long as you're able to understand, okay, when are we applying the chain rule? Where do the parentheses go? Those are usually the biggest trip ups here. And so if you can do this one, I guarantee you can do any one toss your way. So keep that in mind. It does get a little bit tricky, but try and work it. Make sure you can do it on your own and whatnot. So that's what we're looking for there. Alright, last but certainly not least, we have two problems. We have f composed with g prime of 2, and then g composed with f prime of 4. So the first thing to take note of, if you have the derivative of f composed with g of x, we mentioned that that has to be f prime of g of x times g prime of x. Okay, so in our first problem we have f composed with g prime of 2. Alright, so what that means, that's f prime of g of 2 times g prime of 2. So first off, let's look for g of 2. Okay, so here's g of x, is that red one, and then it looks like there's when x equals 2. So notice what pops out is 1. So we can rewrite this as f prime of 1 times g prime of 2. Okay, well that's nice, because f prime of 1, remember this is slope of a tangent line. At x equals 1. That's all it is. Okay, so since it's a slope of a tangent line, that's what we're looking for. Yeah, so I see you have a quick question. Go ahead and type it in there, Amber. What's your question on? Yeah, feel free. Anytime you have a question, you can just type it right on in, and I'll be happy to kind of address it there. And so when we're looking at this thing, what we're looking for is slope of tangent line, just an FYI. And we have a line, so all we actually need to do is take the slope of the line of f here is going to be our big goal as to what we're looking at. And so in terms of what we have, here, we'll get the 2 points. In the meantime, you have 0, -3 sitting right there. And then the other point will be 3, and then we go 1, 2, 3, 4. So yeah, and I have my eyes on the question, so if there's any point, you just kind of direct me which slide. I'll be happy to answer the question. Just let me know. That's what I'm here for. So go ahead and type it on in, and I'll get right to it. So on this one, finding the slope of that f function of that line, because it's a straight line supposedly, all we need to do is take the y2 minus y1, so you go 4 minus a -3 all over, it'd be 3 minus 0. And because we were doing it at so you might be saying concerned, because it's going to be at that point right there is what we're looking for the slope of the tangent line. But notice this whole line for the f function. Since it's a line, it's going to all have the same slope. In a similar manner, we're looking for the slope of this line for g prime of 2. Notice that's downward. So what happens here? Well, you need the 2 points. So in this case, what do we have? 1, 2, 3, 4. So this point right here is 4, -3. And this point right here is 1, 2, 3, 4, 5, 0, 5. Okay. So in that case, we do the y2 minus y1 thing, and so you get -3 minus 5, and then all over 4 minus 0. And so what are we left with? Well, we're left with 7/3 times -3 minus 5 is -8/4, and that makes -56/12. So I know there might be a delay there, Amber. If you have a question, is it on the graphs, or is it on a previous slide? If you could just let me know, and I can kind of go back to there before handling the next piece. And all you need to do is just type it in there. Okay. So Amber's question is, on the last problem, can we combine derivatives, or do we always have to go step by step? Specifically, the derivative of the square root in the x cubed minus 9x squared. Okay, so the question was, can we combine this, I believe, to be 1/2 3x squared minus 18x to the -1/2, right? And I'll just kind of illustrate real quick. So we're comparing that to what we had with the 1/2 x cubed minus 9x squared raised to the -1/2 to the 3x squared minus 18x. Okay, so to kind of get our bearings with what's going on here, what I'd say is the easiest way is to plug in a value, see if it matches. If they match, then you'd say, okay, well, you don't necessarily know it matches for all, but it gives you an idea as to what's happening there. Now, just you can't pick 0 because that really doesn't tell us anything interesting. You have 0 and 0 on both sides, but what you'll start to see if you plug in a number like, so we need to find the domain too. Let's say we did, let's see here. We need to pick something that's big enough. So for example, and I'll need a little bit extra room here. So just so you can take a look and see what's happening. And these are the types of things you want to see, right? You want to see, is there a shortcut to this shortcut, or is this going to be the fastest way? So it's a really good question. Are these two the same then? Especially when these things get so complicated. My suggestion would be x equals 9. Plug it in. And notice you get 1/2, and then you get, this thing would be, what would we have? We'd have 9 cubed minus 9 times 9 squared, all raised to the -1/2. Remember, that's going to put it in the denominator. And then 3 times 9 squared minus 18 times 9. Let's see if that does it. So notice this thing would be, you can write that as 2 times 9. And so on the one side, just an FYI, since you have this and a negative 1/2 power, that's undefined, right? So on the other side though, notice you have 3 times 9 squared. And now I could write the other one as minus 2 times 9 squared. All raised, and we have the 1/2 and the negative 1/2. So what does this make? Well, 3 times 9 squared minus 2 times 9 squared. Notice that makes 1 times 9 squared. All raised to the negative 1/2, and then times 1/2. But so you can do this. That's not too bad. So this would be 1 over. I mean, you take the square root of 9 squared essentially, and you get 1/9 times 1/2. So this is actually a finite number. So you have 1 over 18. The other one's undefined. So what happens at the end of the day is, no, you can't actually take that shortcut. It seems like it, but you have to break it down piece by piece. And if you want to see a smaller example to kind of illustrate that, I'll kind of touch on it real quick here. So you actually do have to do this outer minus inner, and you got to go those extra steps. And that was a great question there. You want to always try and check and see, can I do this in a faster method? So let's see. If we did something like x plus 7 cubed, right? So if we want to find this derivative, what some people say is, well, I can just shortcut take the derivative of the outside and then like put the derivative of the inside in there. So if you did that, you'd take 3, and then we'll have this squared, and we'll have derivative of the inside is just derivative of x is 1, and derivative of the 7 is 0. So it would just be 3, right? My claim is that this won't work, and I'll kind of illustrate why in 2 methods. So first off, the chain rule method would say, hey, this is going to be 3 times x plus 7, the quantity squared, times the derivative of the inside. And what is that derivative? Well, it's just 1. So that's what we were making the claim on, right? So this is just 3x plus 7, the quantity squared, times 1. So that doesn't change anything. And if you were to actually multiply this out, you get 3 times x squared plus 14x plus 49, right? If you wanted to do this another way, you can expand this polynomial, and if you don't remember perfect cubes expansion, that's fine. I'll write it out for you. So this would go x cubed plus 3 times x squared times 7 plus 3 times x times 7 squared plus 7 cubed. Now, it seems kind of crazy, but at the end of the day, we can simplify this thing quite a bit. So what's the derivative of x cubed? Well, that's 3x squared. And notice if we distribute that 3, you get 3x squared. So we're good. Okay, what about the next one? Well, we'll get 3 times 2x times 7. Well, notice that's 3 times 14x, which would be what would happen when we distribute that there. And in our last one, notice we have 3x and then 7 squared. The x is just x to the first power, so that just kind of fades into the background there. So this is just 3 times 7 squared, and then the derivative of the constant is 0. But 3 times 7 squared, notice that's 3 times 49, which is what we see right there. So that's the whole idea. We can't just shortcut and take the derivative of the inside. But that's a great question. What you always want to see, can I cut down my time? And so that's important. So hopefully that makes sense. If not, let me know. I'll be happy to explain a little bit more. Great question there. So moving forward on the next one, where were we at? We were at g composed with f prime of 4. So when we go the derivative of g composed with f of x, so this might be a little confusing at first, that goes g prime of f of x times f prime of x. So in this case, g composed with f prime of 4 is g prime, I should say, of f of 4 times f prime of 4. Okay, so let's take a look. First off, we got to find f of 4. So we go 1, 2, 3, 4, and we get, oh, looks like we're right there. And so notice that's going to be 2. So hey, that's not so bad. So that's g prime of 2, which we already know from the previous one. So times f prime of 4. So g prime of 2, if you recall in that previous problem, we found the two values. So you get negative 3 minus 5 over 4 minus 0. And then f prime of 4, what's happening here? So we got to look, okay, what's the slope of this line going right here? Okay, well notice we have the point 5, 0, and we have the point 3, 4. So we can use both those points. We can do 4 minus 0 all over 3 minus 5. And so that will equal, once again, negative 8 over 4. And oh, what I could have done the previous time, I could have simplified that to negative 2. So basically this previous problem, by the way, we could have made negative 14 over 3. And that probably looks a lot nicer to a lot of you. So, and then this other one, what do we have? We have 4 over negative 2. Is that right? Yeah. Okay, so notice that's negative 2 times another negative 2. And so that'll make positive 4. So those were our final answers in terms of using the graphs. So hopefully that made sense. If not, ask a question, let me know. And without further ado, I hope hopefully this made a little bit of sense and cleared up the air a little bit for chain rule, what's going on. If you do have any questions in the future, aside from this live session, please post them. There's a YouTube live discussion board, and there's all sorts of discussion boards. Please post them there, and I'll try and address them in a future YouTube live discussion as well. So hope you have a good night, and I will see you next time.